Okay, here are the answers to the Chapter 8 closure/study guide. So the first section says decide if each of the following equations is a polynomial. If it is, state the degree. If it's not, explain how you know. Remember, polynomials need to be raised to a whole number exponent. So A is yes. And it's got a degree of 3. B is also yes. And it's to a degree of 7. C is no, because the x could be a decimal or a fraction or an integer. So no, don't, no. What x is? We don't know what x equals. D is also no. Remember, the square root of x is equal to x to the 1/2, and 1/2 is not a whole number. E is yes. It's got a degree of 3. And F is no, because x is in the denominator. Problem 8-179 says, where do the graphs of each of the following functions cross the x-axis? So for A, I plugged in 0 and got x minus 2 squared minus 3. So I added 3 to both sides. 3 equals x minus 2 squared. Took the square root. So I got plus or minus the square root of 3. So x minus 2, and added 2. So x is going to equal 2 plus or minus the square root of 3. So it crosses at whatever 2 plus the square root of 3 is, whatever 2 minus the square root of 3 is. For F, I can just set it equal to 0 for B, and I know that it equals x equals 19 or negative 14 is where it's going to cross. Problem 180, write a polynomial equation for a graph that passes through the point 156 and has 3 x-intercepts. So I can change these to linear factors and make it y equals a, x plus 3, x minus 2, and x minus 5. So then I plug in to solve for a. So I do 56 equals, there's my a, 1 plus 3 is 4, times negative 2, because 1 minus 2 is, negative 1, and 1 minus negative 4. So we have positive 16. So 56 equals 16a, divide by 16. I get a equals 3.5. So my final answer is y equals 3.5, x plus 3, x minus 2, x minus 5. Now you can just leave it like that unless it says put it in standard form, and that's where you'd have to multiply everything out. Problem 181, decide if the functions are real or complex. So one way to do this would be to draw a graph and see if they cross the x-axis, or we could plug them in the quadratic formula. So I'm going to do that. So I get negative 5 plus or minus the square root, 5 squared is 25, minus 4 times 4 times 3, divided by 6. So I get negative 5 plus or minus negative 23, divided by 6. So this is going to have an I in it. It's going to be negative 5 plus or minus I to the radical 23, divided by 6. So this is complex. For B, it's the same equation except that this is a negative 4. So when I rewrite it, it's going to be negative 5 plus or minus the square root of 25 plus 4 times 3, because it's a negative 4 divided by 6. So now I'm going to get square root of 73. So negative 5 plus or minus the square root of 73. So these are real. It is 2. So which one has 2? Problem 8, 182, make a graph and have the number type solution indicated. So A has 7 real numbers. So I'm going to go up 1, 2, 3, 4, 5, 6, 7. B has 5 real but 2 complex. So 1, 2, 3, 4, 5. And then this last one doesn't cross. C has 4 complex. Could look something like that. D has 2 complex and 4 real. 1, 2, 3, 4, 5, 6. Uh, 183, sketch the graphs of each of the following polynomial functions. Be sure to label the x and y intercepts of the graph. So I know I have one at 0 because of the x. I'm going to have one at negative 1.5 or negative 3 halves. And I'm going to have one at positive 5 over 2, which is positive 2.5. Then I just make my graph go through. Look like that. For B, I'm going to have one at positive 5.5 and positive 2. And it kisses at that one, so I know it's going to go up. Just kiss right there. It should look like that. 184, simplify the expressions. So for this one, I do 3 plus 7 is 10. 4 minus 2i is 2i, so plus 2i. This one I would draw a box for. So I get 9, 15i, 15i, and 25i squared, or negative 25. So I'm going to get 30i minus 16. For C, again, I would draw a box. So I'm going to get 49. I'm going to get 7i, negative 7i, and negative I squared, or 1. So I end up with 50. For this one, I squared this first, so I get 2 squared is 4, and then I squared, then times 3i. So I squared is negative 1, so this is like it's a negative 4. So I get 3i times negative 4, which is negative 12i. E, because it's to the third power, I know that I to the first power is I, so then I to the third power is going to be negative I. To the 32, I'm going to divide it by 4, and it turns out it's 8. Since it's divisible by 4, it's positive 1. Problem 8, 185, divide. So I make my box. I'm going to have 3 divided by x plus 4. So I know the 2x cubed goes here. So this would be 2x. This would be, or 2x squared. So this would be 8x squared. 8 to get positive, I get a negative 7x squared. So that has to be negative 7x. So this becomes a negative 28x. So I need negative 19. So I get a 9x. This would be plus 9. I get 36. So there's no remainder. So the final answer is 2x squared minus 7x plus 9. Problem 186, so this should be squared, so it should be x cubed. This should be exponents 3x squared plus x minus 5. So it says, use the graph as shown to the right, use to determine all the real and complex roots. I know that it's a cubic, and I know that it has one real root and the other ones are complex. So the one real root is x minus 1, or 1. So I'm going to divide my equation by x minus 1. So x cubed will go here, so x squared, negative x squared. To get 3, I need to do 4x squared. It's going to be 4x, negative 4x, This will be 5x, 5, so negative 5. So right now I have x minus 1 times x squared plus 4x plus 5. So I can't factor that, and I know it's complex, so I'm going to have to use the quadratic equation. So I'm going to do the opposite of 4, plus or minus the square root 16 minus 4 times 1 times 5 divided by 2. So I get negative 4 plus or minus 16 minus 20 is 4. The square root of negative 4 divided by 2. Negative 4 plus or minus 2i divided by 2. So if I simplify that, I get negative 2 plus or minus i. So my roots, I already know one of them is positive 1, comma, negative 2 plus or minus I are my three roots. 187, the roots of a quadratic polynomial are given. Find the possible quadratic equation in standard form. So for this one, I would do x minus 2i and x plus 2i. And then I would use a box to multiply it out. When I do it, my final answer will be y equals x squared plus 4. This one, I'm going to do x minus 2 plus the radical 3. X minus 2 minus radical 3. I would use a 3 by 3 box. I'm not going to show all the steps. Use a 3 by 3 box. When I simplify, I end up with x squared minus 4x plus 1 equals. Problem 188, for each equation, determine the amplitude, the period, the locator point, and sketch part of the graph. So in A, the amplitude, I'm just going to say it's the amp, is 3. The period, there's nothing in front of the parentheses, so it's 2 pi. And the locator point, or the horizontal shift, is negative, I'm going to do it below it, negative pi over 2 comma 0. So it's where it starts. So at negative 2, 0, there's nothing being added, so I go up 3. So I go over 2, 3, and then my next point would be, my next point would actually be here, sorry. So 1, 2, 1, 2, 3. So one cycle would look like that. Okay, the second problem, y equals a negative 2 sine of 4x. So again, my amplitude is 2, or I could say negative 2, just the negative makes me know that it's going to flip over. The period, because there's a number in front of x, is 2 pi divided by 4, or 1/2 pi. So 1 pi or pi over 4. Pi over 2, sorry. Pi over 2 is going to be my period. And then my locator point is going to be, there should be no either, is going to be 0, 0. So my graph will start at 0, 0. It's got an amplitude of 2, but it's going to go down first because it's negative. And it's going to be in between because it breaks it into 4. So in between this one, 1, 2, here. So one cycle looks like that. Problem 189, write the equation. So the first one is y equals the sine of x plus pi over 2. Because it starts at negative pi over 2, but the midline is still y equals 0. For B, it's y equals negative sine of x minus 3. C is y equals 5, it's got an amplitude of 5, sine 4x, because of how close the periods are. And this one is y equals sine of 1/3 x minus pi over 3. Problem 190. So it says use a system below to answer without graphing. What's the solution? So I plugged in y equals 2x. I plugged it in for y. So I ended up with 2x equals x squared plus 5. Subtracted the 2x from both sides. So I ended up with x squared minus 2x plus 5 equals 0. So then I tried to factor it, and it was not factorable. So then I plugged it into the quadratic equation. So I ended up with positive 2 plus or minus the square root of 4 minus 4 times 5 times 1 divided by 2. So I ended up with 2 plus or minus 4 minus 20, which is negative 16, divided by 2. 2 plus or minus 4i. So it ended up being 1 plus or minus 2i. So that was what I got when I solved it. That's just x. And then I could plug back in to find y. So I could multiply it by 2 and get 2 plus or minus 4i. What does the solution system tell you about the graphs? So it tells me that they never cross. Because the solutions are complex.